Hello, in this video, we'll talk about rational exponents. And before we get into the details of rational exponents, let's talk a little bit about square root. Now, you will see that square root is is rational exponent. But keep in mind, and when we talk about square roots, square root, we're referring to this symbol here. So for example, if we have the square root of 5, now it's called square root here. So we can also say the square root of some variable x. Now if x here in this example, if x is a non-negative real number, then the expression square root of x is called positive square root of x. Okay. This means that if we take the square root of x and we square it, if we square it, then this is equal to x. In other words, square root of x is the positive number we square to get x. Now, there is also negative root of x. So we also have, and be very careful, the negative square root of x. Okay? And this is defined a similar way. Notice that this here is still positive. The negative is on the outside, okay, of the root. So that's something to really pay attention. Now, the positive root, let's look at an example. So most of you already know the square root of numbers, right? Let's ask, what's the square root of 64? And this would be 8, because if you take 8, which is a positive number, and you square it, okay? You square it. So this is 8 because if we square 8, meaning 8 squared, okay, that is equal to 64. So in addition, and if we have example, if we have minus the square root of 64, this would be equal, well, we know that the square root of 64, just this here, is 8. But because we have a minus here, yeah, because we have a minus, that minus goes back here. So you can think of this also as the square root of 64, which is 8, and that minus sign drops down. Now be very careful, the radicand here, the inside here, is still positive. Because when the inside here is negative, if the inside here is negative, then we say that the square root is some imaginary number. So by definition, for any positive square root, yeah, for example, if we have the square root of x and we square this, if we square this, that is equal to x, assuming x is greater than or equal to 0, right? This here must be a positive number, has to be some positive number, okay? It's the same. So here, these are square roots. Square root. The same also holds for what we call a cube root. Yeah? A cube root. So the cube root of x, and if we cube the cube root of x, if we raise that to the third power, this is also equal to x. And once again, x has to be greater than equal to 0, because we said we cannot take, well, for cube roots, let's take that here. For cube roots, we don't care if x is less than 0. And I'll show you why sometime very soon, okay, in this video. Now, if we look at the fourth root, okay, fourth root. So now we have the fourth root of x, and we will see that if we raise this to the fourth power, this is equal to x. And in this case, x has to be greater than equal to 0. Okay. This x here must be greater than equal to 0. Notice for a cube root, we didn't put that here because cube roots of negative number exist. And you will see the same thing for the fifth root. If we have the fifth root, we can have any number, fifth root of x, and if we raise that to the fifth power, okay, if we raise this to the fifth power, that will be equal to x. And here, we don't care if x is positive or negative, so we don't say x has to be greater than equal to 0. So the nth root of x, okay, the nth root of x If we raise it to the n power, we get x. So in general, we say, in general, we say the nth root of x, meaning nth root of x, is such that the nth root of x, if we raise this to the n power, that is equal to x. But, 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 x has to be greater than equal to 0, okay, if n is even. And this here is very important. So whenever we take a root and the index of the root, okay, the index of the root is even, then that number under the root sign must be positive. So let's look at an example. Let's say we have the square root of 81. So this is called square root, okay? In a square root, the index, which is really the n, right? That's your n here, square root. The index is 2, okay? So in a square root, we don't write the 2 there because this is called square root. All we do, we write this just as square root of 81. We do not write the index, okay? And you know the square root of 81, what number, when you square it, becomes 81. So that number we're looking for, what number when you square it becomes 81, and that will be 9. And the rationale here, the reasoning here, it is 9 because if we squared 9, that is equal to 81. Okay. On the other hand, if we look at this example, what is the cube root of 27? Okay. The cube root of 27 is what number when you cube it, what number when you multiply it by itself 3 times gives 27, and that is 3. And the rationale here is it is 3 because if we take 3 and we cube it, that is equal to 3 times 3 times 3, which is equal to 27. Okay? These numbers here must always be multiplied by themselves. Yeah. Now, if I ask you, example, what is the square root of negative 49. Now notice that I made the radicand here a negative number. And since this is a square root, n is even, so very important, n, okay, n is even. And when we speak of n, okay, when we speak of n, we're really referring to that number in here. We're really referring to the number there, the index. For square root, we know that it's even. Okay, n is even. And if n is even, the radicand, what I've highlighted here with that yellow, cannot be negative. So this here doesn't exist. Okay. Square root of negative number or imaginary number. Yeah. Or not possible. Or we say this is not real. Yeah. It's not a real or not a real number. And it is not a real number because there is no number out there. If I multiply it by itself, that will give me negative 49. Okay? It is not real, and I can say because we cannot multiply a number by itself to get negative 49. And I know you're thinking, well, what happens if we take negative 7? Well, negative 7 times negative 7 gives positive 49. So it is not negative 7. And if you take a positive 7 and you multiply it by a positive 7, that also gives you positive 49. Remember, the key is that you have to multiply that number by itself. Yeah? You have to multiply that number by itself. On the other hand, if n is odd, then we don't have that problem. Yeah. If n is odd. If we look at n being odd, such as the cube root of 8, negative 8, then this here is equal to negative 3. And the reason is because if we cube negative 3, meaning negative 3 cube, this becomes negative 3 times negative 3 times negative 3. The cube root of negative, that will be negative 2. Sorry about that. If we cube negative 2, okay, negative 2 cube, we'll get negative 2 times negative 2 times negative 2. And when you multiply these two, you get 4. But if you multiply 4 by negative 2, you will end up with negative 8. So once again, the key point is that these numbers here must be multiplied by themselves. So when n is odd, okay, the radicand can be negative. That number can be negative. So The same thing happened for fifth root, but if it's fourth root, it's not possible. Okay? If it's the fourth root, it's not possible. So let me just write a quick review, okay, or common square roots and common cube roots. So for square roots, common roots, and we will look at square roots and then we can also look at cube roots. And we could even look at some fourth roots. Okay. So for square roots, the square root of 0, and that is equal to 0. The square root of 1 is equal to 1. The square root of 4 is equal to 2. The square root of 9, that is equal to 3. The square root of 16, that is equal to 4. The square root, I could go down here, the square root of 25, that is equal to 5. The square root of 36, that is equal to 6. The square root of 49, that is equal to 7. The square root of 64, that is equal to 8. Moving back up here, the square root of 81, that is equal to 9. The square root of 100, that is equal to 10. The square root of 121, that is equal to 11. The square root of 144, that is equal to 12. The square root of 169, that is equal to 13. The square root of 196, that is equal to 14. The square root of 225, that is equal to 15. And the square root of 256, that is equal to 16. So these are some common square roots, okay? Now for cube roots, okay, we have the cube root of 0, that is equal to 0. The cube root of 1, that is equal to 1. The cube root of 8, that is equal to 2. The cube root of 27, that is equal to 3. The cube root of 64, that is equal to 4. And the cube root of 125, that is equal to 5. Okay, so these are the common cube roots. Okay, we also have fourth root. The fourth root of 0 is 0. The fourth root of 1 is 1. The fourth root of 16 is 2. The fourth root of 81 is 3. So there are fourth roots out there also. Yeah. So if we look at one of the properties of exponent, and we have a to the n power raised to some mth power, that is equal to a to the n times m. Another property is a to the n over m power. The denominator is the index, so this becomes the root of a to the n. And if you look at this example, the cube root of 8, it is understood that for 8 we have a 1 power there, which we generally don't write. So this becomes 8 to the 1/3 power. So generally, roots can be written as some rational exponent. Okay? The root can be written as a rational exponent. So now that we've seen this, we can work out examples of roots or rational exponent. So if we look at an example, okay, and I said to simplify, if I ask you to simplify this, and I give you the cube root of x to the 6th, y to the 12th. Well, it will help if we rewrite. Why don't we rewrite this as x to the 6th, y to the 12th? Everything raised to the 1/3 power, because cube root is 1/3 power. And using the property of exponent, the very first one I've listed here, okay, we can now distribute this exponent to the exponents on the inside. And by doing this, we have x to the 6/3 times y to the 12/3. And 6/3 is the same as 2, so this becomes x squared. And 12/3, 12 divided by 3 is 4. Okay. So here we have x squared y to the 4th. Okay, that's our final answer. Now, if we look at another example, and I ask you to simplify, now if I give some number in there, such as the square root of 81, a to the 12th, b to the 10th. Well, first, let's rewrite as we did above. If we rewrite this, we have 81, a to the 12th, b to the 10th, raised to now. Remember, this is square root. We don't see an index. So when we don't see it, we know it's a 2. And that's why we call it square root. Okay? Now, be very careful, because when you don't see a power, it is understood that that power is 1. Okay? And if you distribute now 1/2 times 1, 1/2 times 12, 1/2 times 10. So we end up with 81, okay, to the 1/2 power, a to the 12/2 power, and b to the 10/2 power. And remember, 1/2 power really means square root. So the square root of positive 81, okay, is 9. Okay, this is square root. And A, 12 divided by 2 is 6, and B, 10 divided by 2 is 5. So we have 9A to the 6, B to the 5th. So here we have our final answer. Now we do have a theorem. And theorem in math is things we don't have to prove, we just use them. Yeah. If we have A to the n divided by n, this is the same as if we write A to the 1 over n times m. Because when we distribute what's on the outside, we will still get A to the m over n. Or it doesn't matter, since we multiply, the order of the multiplication doesn't matter. So we can also write this as A to the m raised to the 1 over n power, right? We are multiplying, so the order for multiplication doesn't matter. Okay, 2 times 3 is the same as 3 times 2. And that's the same as the fraction power. Okay? So we will use this, and I just wanted to point out this theorem to you. Now, why am I showing you this? This will help you if we have an example and I ask you to simplify it. If I ask you to simplify, what is 8 raised to the 2/3 power? Okay. Well, remember that the denominator tells the root. Okay. 3 tells the root. So I can rewrite this. I can rewrite as 8 to the 1/3 power, and then we square it. And the reason I'm writing 8 to the 1/3 power, because this here is the same as the cube root. This here is the same as the cube root of 8. And the cube root of 8, we know, is 2. So we now have 2 raised to the 2nd power. Yeah. And 2 raised to the 2nd power, we know, is 2 times 2, which is equal to 4. Now, I always choose to write the cube root first. Okay. Now you will see that if I did it the other way, right? We had 8 raised to the 2/3 power, to the 2/3 power. You will see that if we rewrite it, okay, just as how I rewrite it over here, rewrite, and now we rewrite this as 8 squared, and then I raise it to the 1/3 power. Well, 8 squared, that becomes a big number. That is 64. But now I take the cube root of 64. And the cube root of 64 is 4. Okay. This is the same as the cube root of 64. And the cube root of 64, we know, is 4. So we do end up with the same answer. The reason I take the root first is because I don't end up with big numbers. I don't end up with these, or I don't have to take roots of these large numbers. So it's a matter of choice. It's all a matter of choice. What do you want to take the root of? It's totally a matter of choice. Yeah. So let's try a different example. Simplify. What if we have 25 raised to the 3/2 power? Well, I will rewrite this as 25 to the denominator power first, 1/2, and then I will recube it. And I know 1/2 means square root, so the inside here is the square root. The square root of 25 is 5, so this becomes 5, and then I cube that. And if I cube that, this becomes 5 times 5 times 5, which is equal to 125. If we look at another example, how about if I ask you to simplify, and now I have 9 to the minus 3/2 power. So I can still rewrite this as, and we have here 9, the denominator is a 2, so this becomes 1/2, and then I have a minus 3 power on the outside. We know that this here means square root. 1/2 power is the same as square root. So this portion here is 3. And then we raise that to the minus 3 power. Now be very careful. This is I strongly suggest you watch the video on properties of exponents that I have online. This here does not mean -3 times -3 times -3. You have to write positive. Rewrite using positive exponent. So this becomes 1 over, okay, 3 to the 3rd power. Okay, this negative here means 1 over whatever you have there and drop the negative sign. So now this becomes 1 over 3 times 3 times 3. Let me, it's a little bit longer. And finally, this becomes 1 over 27. Okay, becomes 1 over 27. So you just have to look at this and see, okay, what powers you're using. Now, I mean, additionally, I can give you some examples using properties of exponents. If we have x to the 1/2 times x to the 5/6, since the base is here the same, you know that we add the powers. So we keep the base and we add 1/2 plus 5/6. And if you add 1/2 plus 5/6, this becomes, the common denominator is 6. So this becomes 3 6 plus 5 6. So we have x to the 8th sixth, and 8 6 can be simplified. So this is equal to x to the 4 thirds. Okay. So the rules are the same. The rules are the same when you add, when you multiply, divide, or distribute. The rules are the same. Okay. Example, if we have, let's say, a to the 2 thirds, and if we raise that to the 3 fourths, well, this is the same as if we write a, and remember we always multiply, so 2 over 3 times 3 over 4. So we have a, 2 times 3 is 6, and 3 times 4 is 12. And we can simplify this. 6 over 12 is the same as a to the 1/2 power. Okay. When we divide, if we have b to the 1/3 divided by b to the 1/4, the bases are the same. When the bases are the same, we keep the base and we subtract the numerator, which is 1/3, minus the denominator. Always the numerator first. Okay? Numerator minus denominator. Always. So this becomes b, the common denominator is 12. Yeah. So this becomes 4/12 minus 3/12, which is b to the 1/12 power. And please be careful when you write your exponent. These are exponents, okay? Another example. What happens if we have a to the minus 1/3 divided by b to the 1/2? All of this raised to the 6th power. Now remember, parentheses first, inside the parentheses first. And please leave the negative exponents for the last simplification. Don't try to make negative positives at the beginning of the problem. So notice that the base here are different. So there's nothing you can do inside the parentheses. Okay? There is nothing to do inside of the parentheses. Additionally, if you want, you can write this as, this is the same as if I have a to the minus 1/3 power raised to the 6th and b to the 1/2 raised to the 6th, either one of them, okay? These two things are the same. Now, if you do this, we know that whichever case you do, you have to distribute, okay? The power has to be distributed. So if we distribute, we get a, and if you multiply negative 1/3 times 6, you get negative 6/3 over b to the 6/2. And if we simplify this, we get a to the negative 2 over b to the 3rd. Now, in my previous video, what I said is look at the, or not previous video, but one of the videos, if negative is on the numerator, you cannot leave, first of all, any answer with a negative power. Cannot do that. So what we do, if it's negative in the numerator, by bringing it to the denominator makes it positive. The power on the b is already positive, so that stays where it is. And you can't leave the numerator without anything. There is a 1. Keep in mind there is a 1 here, right? So this is our final answer. And we will see more examples of exponents here. Okay. So the last example I want to look at, example, simplify. How about if we have x to the negative third, y to the 1/2, all of this raised to the 4th power, divided by x to the 10th, y to the 3/2. Well, keep in mind inside parentheses first, right? So you always look inside here. Can you simplify anything in there? Since the bases are different, okay? The bases are different, so there's nothing you can do. So the only thing we can do now is to distribute that 4. So we have x to the -3, y to the 1/2, and this 4 power there. The denominator stays the same. And what I'm going to do here, I'm going to distribute that 4 to the -3 and that 4 to the 1/2. By doing this, we get x to the -3/4, y to the 4/2 divided by x to the 10th, y to the 3/2. Now you can simplify this if you want and write 1/2, but I'll leave it for now, doesn't matter. Now notice that this base is the same as this base. So when we're dividing, we subtract. So -3/4 power minus 10 over 1 power. And also note that this base is the same as that base. So this becomes y to the 4/2 minus 3/2. Now what we have to do is combine these two fractions and both x and y's. So we have x, the common denominator is 4. So this is a -3. And then this becomes 40. And then with the y, common denominator we already have. So it's 4 over 2 minus 3 over 2. So this becomes x. Okay. And we combine the power here. Just observe that there's an error. Let's go back. When we multiply 4 times -3, this becomes -12. Okay. This is -12. So here we have -12 over 1. So we don't need a common denominator here. Okay. And we don't even need to write this as fractions if we want. We can just say -12 minus, this is the numerator, minus the denominator, which is positive. So this becomes -22. Okay. So -22, x to the 22, and y, 4 minus 3, becomes 1 over 2. Now, keep in mind that if we write this here as a fraction, okay, if we write this as a fraction, there is sort of an invisible 1 at the bottom. And I said to you that if the power is negative in the numerator, by moving it to the denominator, it becomes positive. Likewise, if it was negative in the denominator, by taking it to the numerator, it becomes positive. And the y to the 1/2 stays in the numerator. Yeah. So now our answer has no negative power. And that's our final answer. So, as always, I say at the end of my videos, please practice more problems, or it is your responsibility to always try more problems. I'll see you in my next video.